The remainder obtained when the polynomial p of x given here is divided by x plus 3 is twice the remainder obtained when p of x is divided by x minus 2. We're given that p of x is divisible by x plus 1 and we want to find the values of a and b. So I'm going to deal with this last fact first, the given that p of x is divisible by x plus 1. What that tells me is that p of negative 1 is equal to 0. So p of negative 1 is negative 1 cubed plus a times negative 1 squared, take away 3 times negative 1, add b, and we know that that's equal to 0. So that's negative 1 plus a plus 3 plus b is equal to 0. So a plus b plus 2 is equal to 0, and therefore a plus b is equal to negative 2. And I'm going to call that equation 1. So now let's go back. So when it's divided by x plus 3, we know the remainder would be p of negative 3. And we're told that's twice the remainder when divided by x minus 2. So that's going to be twice p of 2. So that's going to give me negative 3 cubed plus a times negative 3 squared, so that's 9a. Take away 3 times negative 3, so that's going to give me a plus 9. Add b is equal to twice. We use 2, so we get 2 cubed, which is 8. And then 2 squared is 4, so that's going to be 4a. And then negative 3 times 2, so let's take away 6. And then we've got a plus b on the end of that. So we've got negative 27, add 9a, add 9, add b is equal to twice 2 plus 4a plus b. So this one is 9a add b, take away 18. That's going to be equal to 4 plus 8a plus 2b. If I subtract 8a from both sides, I get a. If I subtract 2b from both sides, I've got minus b. And add 18 to both sides, I get 22. And let's call that equation 2. So now doing equation 1, add equation 2, I end up with 2a is equal to 20, 22 add negative 2, and therefore a is equal to 10. And if we substitute back to here, so we've got 10 plus b is negative 2, that must mean that b is negative 12, and just check that does work in the second equation. So a is 10 and b is negative 12.